definitions, some ordinary bolt, high-strung bolt, and how to divide it. And also arrangement for the bolts in the connection between plants, steel plants. Now, so the arrangement requirements for the loading, we need to keep the eye distance should be bigger than 2 times the diameter. And for this and the structure for the bolt, the structure requirements is side distance and the middle distance should not be to be large to avoid the moisture interesting. So for the erosion of the water or other things. For the construction requirements, we should keep some certain construction space and easy to turn the bridge and easy to fix it and attach the boat, right? Okay, here is the tables. When we do the installation of the boat, we should follow in these tables. The distance, minimum arrival distance from each, and the maximum distance between the boats. For example, if we have a plan how to arrangement the boat according to these tables, right? And in your country, in different countries, in Europe or in Africa, Americans all have tables. You should follow in this. Well, after we fix the boat, we should check the strength. So we should know the basic force transmission model for the boat. And we know how many force applied in for one boat. For one boat, it will, for example, this case, we have three boats, three lines boat applied in here, right? For one side, A side, this is A. For example, this is A side, this is B side, this is C. So now we analyze the force for each boat. You can see this is boat, and instead here I will plot the figure as a force. Right? This is boat. So can you analyze for the A how the force systems, balance system in the A? Which force applied on this boat? Which force applied on this from here? Tension. Very good. Does it apply any shearing stress applied in this boat? Shearing. Does it have the shearing stress? Yes or no? Yes, sir. Right. But for this boat, we can see I zoom this one. So, but for this C type, which force applied on here? Shear force. The broken will be shear broken, right? This will be tension broken. Okay. This is the basic type. So now we know we we know that one thing. Sharing and normal force. Two types of the applied on the we can see that. So for shearing bolt, normally transfer the shear by bolt shear and shear stress and the hose wells pressures. So for shearing bolt, it will be the shearing strength should be enough to bear the applied shearing stress, right? And the tension bolt is also the tension strength should be enough to bear the shearing stress, the tension stress, right? This is the principle for you for the design of the bolt. So we can see that shearing bolt, the theory models. Shearing bolt when the shear is between they will be broken, and here also will be tension or will be compression with surface, right? This is two types. One type is directly showing it's broken happens in this interface middle of the broken happens in on here, right? So for this case, how do we analyze this one? We found the force F. We calculate distance, areas, cross section areas for this one, right? Found these behaviors to compare material behavior, right? And for this case, how do we analyze the case? This also force over the areas of this side, right? We discussed in last class. The A should be smaller than F, right? This A1 and A2 is different. Clear? This A1 and A2 different, so you can compare. For example, this sigma 1, this is equal to this is sigma 2. We choose minimum sigma to compare the F. Clear? So this is broken type. This you can see that which here is tension broken. You can see a big broken through the tension paste, right? This is tension and broken the top of the material. This is showing the broken. You can see this is the for displacement is opposite. It is different side. It's broken in this type. The cross section area, broken cross area is here, right? These areas you can calculate in this site, right? So so we use the formula equations to describe the behavior. This is the calculation of the design very complexity of the shearing force. We discussed they have two types behavior. One calculation we use this equation. Do you know the meaning of this equation? Nothing. Okay. And explain you. I will explain for you. Before I ask you, firstly I want you to analyze by yourself. Perhaps, what's the meaning of this equation? Check it. 文琪 Now you are teacher.
Yes.
Tell everyone what's this meaning. What's this equation meaning? Who wants to be a teacher?
Hello.
I want to Elisa. No. Be confident. Okay. So no one wants to explain you for George.
Yeah.
John is
So smart.
Yeah, so smart. He's so smart.
come here.
Yeah. Go.
You know?
Yeah, he knows.
Okay. So long you want to
I think that Pioneer Square.
you can guess everything for this case.
Yeah.
You can guess it here. I want to find you if you careful, if you're clear.
Oh. Let me guess. Yeah, I think this is area.
That's
This area and this side. Both. So. So it's like area. It's like it was.
Yes.
Yeah. So it's like most of the area equal to stress, right? Yeah. So and the stress is equal to N.
So M, what's the M?
This one. I think it's number.
Very good. Okay. I think you can get up. You can come. You don't need a single class. You're clear. Okay, come here. Let me still explain this. Explain for me for this. Later I will explain you very clear for you. So can you guess? John Kelly, can you guess what's the meaning of this case? Chen Wenqi, do you know this the logic of the surrounding? Do you know this one, and this one? Don't know.
No.
Okay, I will explain for everyone. But anyone know this case? Know this? Try to understand this one. 于子乔 can you teach us? Katenda.
The T is what's confusing. I think that the T is those two things.
T is what? T is what?
I don't know when you're saying
Okay. I can slow your logic. This is time. This is what?
this distance. I mean,
This is distance.
So velocity.
So time point distance is what?
Velocity.
Velocity is over. Can you think about it again?
T is diameter. T is the number of those two things. My plates under tension.
Okay. now it's my job. It's my job. Okay. Your time is over. So for salam, this one you didn't get the very clear understanding, right?
Yeah, yeah.
And this one you guess it. I think it's right. And the principle of this one is right. So this one is time is totally wrong. This one time is distance is okay. It can be explained. For okay, they have also a behavior of FCB, right? It's FVD. Remember, we compare normally F over the A, compare the F, right? We call this F is the material behavior, right?
Yeah.
So this is the material behavior of the boat. This V is comparing the strain stress, and the C is comparing the compression stress. Okay, maybe you don't have very clear. It's not very clear. I will show you in blackboard. So we apply this is plan. We use the boat to fix it. Is it right? Is it right? They have Fn applied on here, right? This is the F. In your mind, the stress first type, the stress broken will happen on here, right? So F over the A, right? You can see the strain bearing this one we have 2A, right? 2 points the A. Should smaller than F, the material behavior of that is right. And then you can see we number this is N, right? This is diameters. Point the F should be smaller than F, B, F. Is right? Can you understand? So we can get for the case the F minimal is what for the F maximum F it should smaller than this one N point. Is right? 问题 can you understand? Can you understand? So we can get the force. The force should be agree this principle, right? Now you can come see here. This is agree this principle, right? So what's the meaning of the M and B? What's the meaning of the MVB? Anyone know that? Oh, sorry. the meaning of the B? What's the meaning of the F?
False.
False. This is false, right? So means when the force bigger than this value, it will be broken. 很正常 is right? Justin, is right? What's the meaning of the F? Yes, means the force bigger than this value. This bolt will be cutting, broken, right? Oh, this is one case. Now you can know each parameter. Normally we use this to compare this VB. To describe this behavior, right? And also have another case. Sometimes it will be the broken will be happens on here, on this surface. Okay, I plot down. They also have the broken also maybe also happens on this surface. Assume this here, this surface. We need this is the column. Okay, we will not recognize this column. It should be like the column, right? So. The column, this is D, this is T, right? We determine the side which should be, according to this behavior, which should be found the areas, right? The T, and this is the, so the T means, this means the time. This means the time. This means the time. Yes or no? No. Right? This is size. This is size of the part. And then now we found the distance. What's the distance? D is where? If we found the cross section areas, D should be where? D will be this long distance, right? So if broken happens in these areas, we can find the F should be the F over the A equal to F over the D point T, right? Equal to D. And it should be smaller than very complexity of the C, of the comparison, right? Okay, this is D, this is T. This is D diameter, this is T. The distance. Okay. Diameters for this one, T is this one, the height. Understand? So you can see the showing, they have different height, right? Different height, we should be the sum of the T. Clear? So we can get an equation. F, for this case, F should be smaller than T. point G, point F, C, F. Right? Can you understand?
I'm confused now.
Confused where?
See, the first part where it says 2 times area.
2 times earlier. Okay.
Yeah, from there, I don't know.
Okay, we forget all this thing about here. We just focus on time. This cross section is where a force will produce two areas, right? Two interface. So we come back. For this one, we have how many interface of this? For this case, how many interface? One. For this case, how many interface? For this case, 4. 1, 2, 3, 4. Right? Now you see here. This is what for this case they have 2 interface. So this one you can understand. Clear? So you can see the case down for this case. And what can you understand for this case? So we mark the NCB to mark it. So this ends. These 2 pyramids will what? The strength of the bolt will depend by these 2 pyramids, right? 1 and 2. Right? Depends this one because the bolt will be applied for these two stress. Clear? Clear?
Those letters B, N, B, V, and N, B, C. What do they mean?
Okay. C means this force, compression force for the interface, for the face. The V is normally we define the shearing stress as a V. Clear? You can demand you don't need you can change this by yourself, but you know this one. These 2 types of the force. Very simple. One thing is you can see the white colors. One thing the force showing stress applied in this surface is broken. One thing is the force applied, the compression force makes it broken. Right? You can imagine when the 3 pound when you can imagine 2 force applied in this one, right? Sometimes it will be broken on here, right? Sometimes maybe it will broken produced in here, right? Clear? Maybe because they also have a force, normal force, contact force. The force will be compression this bolt, right? And to make the bolt have a big compression force and make destroy the force, broken the bolt, right? Okay, now you calculate two force, VB and CB. We choose a minimal values to determine the showing the force, the bearing capacity. Clear? This is we choose a minimal values for NVB or NCB. Know that? Get this is this one. This means a single bolt, the bearing capacity of the single bolt. It didn't like the wording. For the bolt, they have more force applied on here. Clear? Yes or no? Clear? Yes or no? No.
Again?
So the okay. Yes or no? No. You mean K and OW or you know it? Yes or no? No, you don't know. Okay, I know. No, come back to see this one. I use a new page. Now we make it simple. I explain you very clearly. For example, this is two planet. If you don't know, please listen very carefully. Now this two planet, right? Now your job is connection these two planet. We apply what? This is both applied on here. We suppose the one broken will be produced. This means broken here, right? Showing broken. So we can get the data is what? F over this closed areas. A should be smaller than F. F means the V showing stress of the bolt, right? Showing capacity of the bolt. So the F for a single bolt, the F will be smaller than A point FVB. Here you can understand.
Yeah, yes.
And then should F should be smaller than A equal to what? 4 over diameters.
That's right, 5 and square.
Pi
R squared.
R squared, right? Point FVB. Is it right? Now you can get, you know that, but this is only have one interface. We point this n equal to here. This n will be equal to 1, 2, 3, 4. Depends your arrangement, right? So this one we named it. We named it as the bearing capacity of the shring for the one bolt. Clear? Clear? Okay, a new case. Okay, make it. Before that, I need you know it very clearly for this one. Clear? Good. Next page. Also the same case. Your mention is connection. So we also use a bolt to fix it. choices. So now this block is we analyze the suppose didn't happens on this surface. It will be happens because they have a force. In this interface, right? We tension this one. Okay. Should be a force distributed only here, right? The force we stressed will be destroyed this boat, right? So destroyed. Now this is 2D. When the 3D problem, this is cycles. Right? This is 3D. The interface, this is this distance d, the diameters, right? And this one is t, right? So we found the areas F, because this force is applied in this direction. Because the force applied on this direction. Right? So the areas we should be calculated this surface, right? We suppose we calculate this areas. So now we have the first equation. F we still beginning from the F of the A. Right? Equal to what? F over the B T. For example, this is different. The force contact normal force applied in this area, right? This is B T. You can find this is T1, T2, right? So we sum the T, right? It should be smaller than F. The material behavior of the compression of the boat, right? Of the boat. Now we can relax, have a break. Okay.
Can find some shit.
Chinese one.
How much?
Chinese.
They're mixing like a German and saying English. Man, slow. The wrong way in the future too.
I can't make.
I think you.
All of us.
I must start eating so. Looks like.
I have a question for you. I analyze in here is to why you don't understand. Didn't understand because too much things in here information. So if I separate simple
Yes.
side by side,
Side by side.
okay, I know that.
This one. This is Shinji.
我又听到中文了，我又听到你标中文了。你刚才说什么？很多信息，
很多信息。
主要的信息不是 meaning 的信息，
信息。
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 信息不是信息。
I forgot, but is to know.
You know that 信息 means information.
Yeah.
If you are great, I can speak Chinese for in the class.
After class, if we come to teach him English.